All right, here we go with our chapter on vectors. So you might have learned about some vector work in physics, maybe. You probably see it there. And so when we do these things in this chapter, there are other ways to do them besides this way, but this is the way I'm going to show you. So anyway, what is a vector? So you have to remember a vector has two things. It has a direction and it has length to it. So it is a directed line segment. Oopsie. And it might be confusing because we put an arrow on the end of the vector. So like when you draw a vector, you start somewhere and you go like there, and we put an arrow, but it does stop right there. We're just trying to imply like, hey, it's going that direction. And so it has a length to it and it has a direction, okay? So a scalar, when somebody starts saying that word to you, this is just a single real number. Okay, so like when you multiply a vector by a scalar, like let's say this is called vector A or something. Like if I want to do 2A, what I would do is I would double the length. I'm doubling A, so I would start here, I would go the same direction, but I would do something twice as long. So when you multiply a vector by a scalar, it could change direction, it could make it shorter or longer, but it changes the vector in some way, okay? But it still has direction and magnitude, or length. All right, so let's decide which one of these is a vector, which one's a scalar. So remember, we have to have direction and length to our piece. So when somebody says you have a boat traveling at 15 miles per hour, well, great, they told you the speed, so they kind of told you like the magnitude in a way. They told you a number, but they didn't tell you what direction. So this is just a scalar value. All right, a hiker walking 25 paces due west. So not only did they tell you a length, they told you a direction. This would be a vector. So some of your homework, the first part, there's questions like this. All right, so a car traveling 60 miles per hour, 15 degrees east of south. So we'll talk about what that means later, actually now, but vector. So when somebody says east of south to you, north, south, east, and west. You have your compass there. And so when somebody says east of south, that's how you say it. So here's south. So east of that would be this direction. So when they tell you that, that means that you're going this far by 15 degrees. Okay? So it's 15 degrees towards east when you're starting at south. So that would be that direction. All right, a child pulling a sled with a force of 40 newtons. Well, they didn't tell you what direction it was going, and they just told you the force, so that is a scalar. So if you want to, you can write your own example of a vector. Okay. So you could say me walking 5 blocks east or something like that, however, whatever you long you have direction and length. All right, so some key vocabulary here. So initial point. When you have a vector, the initial point is where you start, all right? Like your starting point. Your terminal point is your ending place of a vector. Ending point. All right, so if somebody tells you the initial point, the terminal point, like on a graph, that's where you start, where you stop. The length. So the length of a vector is basically its magnitude. These are the same thing. And so the way that you put this, the length or the magnitude, you denote it like this. If you had a vector v or a or whatever vector you're talking about, when you want to know the length of that vector, the magnitude of that, you put these lines around it. So you could see it like this, or you might also see it with a double line, depending on the book that you use or whatever. But that means its magnitude. That means the length or the strength of that thing, right? So, so anyway, things like 25 paces due west. West is your direction. 25 paces, that would be your magnitude of your vector. 60 miles an hour, that's your magnitude. This is your direction that you're going to go. So this is how long your vector is going to be, and then this is the direction you're going to draw it. Okay, when a vector is in standard position, it is said it's basically placed at the origin. So basically the starting place, the initial point, is the origin. Okay. Okay, so what we often do if we have a vector that is not in standard position, we often can make it in standard position by doing what's called a component form. So this would be the x and the y value of your vector, and we'll talk more about that later. But let's say we had a vector that started at -4, 2, like this is my initial point, and let's say it ended at 1, 3. Let's say this is my terminal point. So let's draw that over here a little bit. So if I go to, -4 and then up to 2, start there, and then I'm trying to go into 1, and here's 3. So there's that vector right there. So this xy value is basically like, what have you done to get from here to here? Well, you've gone to the right a certain amount and you've gone up a certain amount. So, right, left is your x value, up and down is your y. It just so happens from the beginning to the end, I've gone positive in both directions. So it's a little bit like your slope, but not really. All right, so I've gone to the right, let's see, for 5 units, and I've gone up 1. So the component form of this thing, this vector right here, would be the vector 5, 1. So it's just about the x and the y value, like from beginning to end, how far right and left, which direction, negative or positive, and how far up or down. Okay, so basically what that does for me is this. If I want to take this vector and basically move it over here to start at the center. So if I were to do that and to redraw it, so 5, 1 would tell me any place I want to start. If I go right 5 and up 1, that's that vector. So if I start it back here, it would go over to the right 5, up 1, and so I could like redraw that vector anywhere I want. I could put it on the end of another vector or do whatever I need to do. Okay. All right, so there's your basics right there. So now we get to some bearings. All right, so we have 2 different kinds of bearings in this section, and we're not going to use these a whole lot, but just so you see it and you're familiar and say, oh, hey, I've seen that before. When somebody says to you, this right here, 60 degrees, and they have different directions on the other side. So you would say this 60 degrees west of south. So north-south is always like your main axis right there. So you're going to go, if you're going south, you're going west or east of that. If you're going north, you're going west or east of that. Okay, so that's how you set it up. This is always north or south. This is always east or west. Okay, so you say this 60, so you kind of skip this 60 degrees west of south. So if west of south, so I'm going south, I'm going 60 degrees west of that. So this would be 60 degrees this way, and then that's how I'm traveling. So I didn't tell you how much or how fast or anything like that, but this would be 60 degrees. So when you're drawing something, then that's what you're doing. So, obviously if that's 60, there's 90 to spend, so you got 30 right there, right? So sometimes you have to kind of know some geometry there. All right, when somebody tells you it's called a true bearing, when you just see this, true bearings just go off of north. So basically they're saying to you, hey, you're 95 degrees off of going north. So it goes like this. So you're basically 95 degrees there. So that's 90 plus 5 more. So if somebody is giving you that, it's just off of north, like to the right. So that would be 95 degrees. Why do I keep writing different numbers than I want to write? So 95 degrees. And, so obviously this will be 5 degrees right here. And then 90 from above, so if you need to know this little bit, that would be 5, but okay. All right, so all these definitions down here, what are parallel vectors? So just like parallel lines, so vectors that are parallel, they go the same direction. So same direction. Like they have the same slope to them, like I guess direction might not be the best word. They have the same angle to them. So like for instance this, if I draw one vector going like this and another going like that, they're going opposite directions, but they're parallel to each other. So same direction, we'll say slash slope. All right. Same angle to them. All right. So yeah. So you could also draw them going the same way, right? They can be the same length, like whatever. But they have, they're parallel, like parallel lines. All right, equivalent vectors. So these ones have to have the same direction. So basically they have to be parallel and the same magnitude. So basically they're literally equivalent. So if you draw one going like this, the other one goes like that, like same. Okay, same length, same magnitude. All right, opposite vectors. So opposite vectors, they are the same magnitude, so the same length, but different directions. Opposite direction. All right, so like if I draw one like this and one like that, those are opposite vectors. They're going opposite ways. Okay, so if I was writing it, I'd say, oh, here's vector v, usually put a little arrow above it, v and negative v. Those are opposites of each other because it's just basically v, but turned around. Okay. All right, so some of your homework is going to have you like take some random pictures and draw them, so I figured I'd show you some of those. It's pretty silly because they don't give you any lengths or any like points or anything like that. That comes later. They're just trying to get you to like get the idea of it or whatever. So if I want to draw 2b, so basically I'd eyeball this and say, okay, well it's going that direction, it's about that long, let me draw something that is twice that long, same direction. So there would be 2b. All right, so you're just eyeballing it, it's nothing specific. All right, negative a. So here's a going this way. If I want to draw negative a, I'd do the same vector, but I'd put the arrow on the other side because I am trying to go the opposite way. Okay, so when you have two together, this is like you are adding two vectors, because remember a minus 3c is the same as a plus negative 3c, right? And so when you add two vectors, you draw the first one. So I'm going to draw a. Again, it's just like an estimate, like obviously they didn't give me anything exact here. And then at the end of A, it's like somebody's telling you two things. It's like, hey, go this way, then go that way. So now they want me to do negative 3c. So regular c goes this way. I need three of them going that way. So here's one of them, another one, and another one. So there I go. So a plus negative 3c or a minus 3c, same thing. What you end up getting is this. You get something called the resultant. All right, so this is a minus 3c. This is that vector because it is the culmination of going this much a in that direction, minus 3c in that direction. So this is the result. So if you were to like travel along this line, then went that way, the result is that you could have just gone from here to here. So the resultant is the answer. So that is what you would draw, but you get there by going here. All right, so we're going to do that, but we're going to be much more specific about it and do it on some graphs. All right, here we go. So vector A begins at the point negative 3, 1 and ends at the point 1, 3. All right, so negative 3, 1, 1, 3. So let's subtract these two. If I want to start at negative 3, 1 and go to the point 1, 3, this is how I'm doing that. So when I want the component form, I do the end minus the beginning. So I do the terminal minus the initial. All right, so I'd be going to the right and up. So if I take 1 minus negative 3, that's 4. And I think these are the same ones I used earlier, right? Oh no, it's a little different. All right, and then 3 minus 1 is 2. So what I'm telling you is that it's to get from the beginning to the end is to go 4 to the right and 2 up. Okay? Vector B begins at this point and ends at that point. So 2 minus 1 is 1. Negative 5 minus negative 2 changes to addition, so that's negative 3. So if I drew it out, 1 negative 2 and 2 negative 5, like that, the result of starting here and going there is to go to the right and down. And so look at that, right and down. Okay, it's a little bit larger. I drew it a little bit off, but that's why we use graph paper. Okay, so what's helpful here is that I now have these two pieces right here. I know what to do. I can start in the middle, and I'm going to do this vector, and I'm going to add that one. So we're going to start in the center, so it's easier to use our component form. So I'm going to do 4, 2. So I'm going to take A, so I can place A anywhere. So I'm going to take the vector that represents A. So from here, I'm going to go over 4 up 2. That's that vector. That's A, right? And onto the end of A, after I finish A, I'm going to add on B. So I'm going to add on 1, negative 3. So over 1, down 3. All right. And remember, like I said on the last page, this is my resultant right here. So the answer to this question is the green thing. All right. So in the picture, this is the answer. But what you're going to do basically is you're going to take this 4, 2, and you're going to add that. So look at this vector. 1, 2, 3, 4, 5, negative 1. So the answer is 5, negative 1. But later, we'll practice it more. Look what happens. 4 plus 1 is 5. 2 plus negative 3 is negative 1. Once you have it in component form, you just get the answer so easy instead of drawing these pictures all the time. All right, so let's do A minus B. So remember, that's A plus negative B. So let me draw A again. It's 4, 2. All right, and then let me add negative B. So B was 1, negative 3. So the opposite of that would be negative 1, positive 3. So instead of doing B on the end like I did here, I'm going to do the opposite of that. I'm going to do negative 1, positive 3. So negative 1, up 3. All right, so the answer is the resultant. The resultant is to go from here to there. So that's 1, 2, 3. 1, 2, 3, 4, 5. All right, oops, that's ugly. So 3, 5. Well, look, A plus negative B. So 4 plus negative 1, or 4 minus 1 is 3. And A plus negative B, or A minus B, 2 minus negative 3 is 5. So again, we don't draw pictures, usually we use these pieces right here. All right, over here, A plus 2B. So I got A again, so let's see, what is it, 4, 2. Okay, and I have to add on 2 B's. So 2 B's, so I'm going to double this. So I'm going to do 2, negative 6. So over 2, down 1, 2, 3, 4, 5, 6. So it's like I did this. It's like I did B once and got to here, and then I did another one to get further along. Okay, so the answer is my resultant right there. So let's count it out. It goes over 6 and down 4. So the answer will be 6, negative 4. Oops, bracket, corner bracket. But look what happens. If I take 4 and add double 2, so 4 plus 2 is 6. And if I take 2 and add double negative 3, 2 plus negative 6 is negative 4. So again, the pictures are just for you to get the idea, is that you take, you add on to the tail, and then you keep going that way, and then your resultant is from the beginning to the end. But just so you get the idea. Okay, so it's been a little bit of time. If you want to take a break, if you're watching this from home or something, maybe take a little break and come back for these. These are going to be a little bit heavy duty here. We would have taken a break in class. So we got some sine rule and cosine rule to remember. So take a little break, maybe get yourself a drink or something, drink of water or soda or something, some coffee. All right. Okay, so I got an airplane flying with an airspeed of 310 knots. So that's nautical miles per hour. No, nautical, not nautical. It's not on the ocean. Never mind. 310 knots. And bearing of 50 degrees east of north. So let's see. So 50 degrees east of north. So that's going to be, here's north. I'm east of that. So 50 degrees this way. So here's my plane flying along. So I want to mark this up. This is 50 degrees. So that means this is 40 degrees. Okay. Then this wind comes in. A 78 knot wind is blowing from a true heading of 125 degrees. So let me draw a little picture of that wind over here so we don't have to mess up our stuff there. So my wind is at 125 degrees. So that's a true bearing, right? So it's 90 plus what, 35? So that right here is 125, okay? This is our wind, and it's doing 78. We'll put this on in a second. I can put 310 right here. So this is 78. All right, so it's blowing from that direction. So it's blowing like this. It's blowing from that direction, okay? All right, so we need to draw that on this picture. So that wind is coming in, it's pushing our plane. So basically what's happening is my plane's trying to go this way, the wind's adding to that, and so the wind's pushing it. So obviously the plane isn't going to go the way I think it's going to go. It's going to be pushed like up this direction instead. It's going to be like pushed over here. So my wind is coming in here. It's pushing off of there. So let me draw another axis right here. And that wind is like coming in from this direction. So the wind is coming there. All right, so remember, this is 125 degrees, you know, from here all the way down. So let me do some geometry with you here. If that was 125 to 180, so let's see, 125 or 180 minus 125, let's see, that's 55, right? So this is 55 degrees right here. So I'm going to put a 55 degrees right here. Vertical angle, this is 55 degrees. So this part right here would be, let's see, also I can get it down here. Look, these alternate interior angles, remember that Z thing? So this one right here is 40, matches this guy. And if that's 55, let's see, 60, so this will be 35. All right, I'm trying to make a triangle here. Okay. Oof. Like I said, told you this was going to be a bit much, but whatever. It is what it is. Okay, and we know that wind is 78. All right, so I'm not going to put that here, but basically I have this triangle here. So the result of me moving this way, the plane trying to move this way, the wind pushing me that way, this is my resultant right here. So I'm going to repeat that little triangle over here. And here's my plane, here's my wind. So this one's 78. This plane is 310 knots. And let's see, I don't know this angle. I do know this one right here is 75. Okay, so I am trying to determine the speed and the direction of the plane. So I want to know the speed of this line right here, the length of that, and also the direction of it. So we need to know this angle, and I need to know this side. Okay, so that's our goal, but all these angles are a little bit confusing. All right. So I cannot use a sine rule because I do not know any side and any angle pair. So I'm going to have to use a cosine rule to find this guy right here. So I'm going to use my cosine rule. This is going to be my A. So I got A squared equals the other two sides, which I do know. So 310 squared plus 78 squared minus 2 times 310 and 78 cosine of the angle 75. Okay, so make sure your calculator is in degree mode. Whoops, make sure your calculator is on, degree mode. You basically stick that in there and solve for A. So if you do that, do the square root to get A, you will get that A equals 299.4. Oops, 0.4 knots. Because that is the length A right there, 299.4. Okay, so now that I know that, this one over here is 299.4, now I should be able to find this angle right here, so because I have a pair. So now I can use my sine rule, 299.4 over the sine of 75 degrees equals 78 over the sine of this guy. So 78 over the sine of, we'll just call that angle B or something, I don't care. All right, so I got to cross multiply. Oops, pencil. So if I cross multiply, I get 299.4 sine B equals 78 sine 75. All right, and then divide by 299, so I get sine B equals 78 sine 75 over the 299.4. So that's some value, and I have to do the inverse sign, right? So I could do sine -1 of that fraction right there. So it's going to tell me angle B. So that comes out to 14.6. All right, so let's go back. So I need to know this angle right here. Oops, let me get my computer back. So I need to know this angle right here, because that will be my bearing, right? And so I just found out that 14.6 is right in there, that this one's 14.6. So 40 plus 14.6 is 54.6. So this angle right there is 54.6. Well, I'm interested in this angle right here. So 90 minus 54.6 is 35.4. So this angle here is 35.4, that's why I want it. So I will tell you that this plane is actually going 299.4 knots, the true speed of it, and it is going 35.4 degrees. This angle right here is east of north, or you could just say a true bearing of 35.4. Okay, so if you're going to be work in a control tower, maybe you know these things. A computer would probably do it for you though. All right, this last one here. So old Heather, she's pushing the handle of a lawnmower. So she's standing here, you know, she's like, has really long legs, she's pushing this lawnmower, and really small head, and with a force of 450 newtons. So she's, you know, pushing down on it, obviously it's moving that way. The angle is 56 degrees with the ground. Find the magnitudes of the horizontal and the component and vertical components of the force. So basically, I just have this triangle. All right, it's a lot easier than the last one. I got 56 degrees, I got a right angle, so the horizontal and the vertical components, this is 450. I want to find this value and this value, right? So if that's 56, let's see, 90 minus 56, is going to be 34. You can do whatever you want. We just use 56. But all I need for here is SOHCAHTOA, right? So if I want to do this one right here, that would be the sine of 56. So the sine of 56 degrees is going to be the y value over the 450. So just multiply 450 times sine of 56, and we will get 373. And that would be 373 newtons, because we're in newtons here. All right, and then, so that would be the vertical component, right? And then if I did the cosine of 56 would be the x over 450. So I just multiply those across there, you get x equals 252 newtons, right? So basically the magnitudes are the lengths of these things, right? And so those are my two answers to that question. All right, so when you do your homework here, let's see, these two will be like the two word problems here that you see. And you know, try them. You know, this one's definitely doable, not too bad. You know, I might get a little stuck on here, but you know, try something. You can draw something and you know, come up with something to do. All right, I know it's a little bit tough. These are just little sketches you're going to make, like we did back here. You're just drawing something like this, okay? And 1 through 6 are some questions like we did on the first page, where is it a scalar or a vector? And then in section 8.2, there's a few problems you can do. Just do the component form. You don't know how to do the magnitude yet. So the component form is just, remember where we found the component form of a vector by doing the end minus the beginning. So that's all you're doing for those, like quick and simple. Okay? All right, we'll see you in class. Bye-bye.